So in this video, we are going to leverage the power of large language model, that is Llama 3 open source model, to build a fast inference chatbot that is capable of handling multiple PDF documents. So we are going to use Groq to run Llama 3. And so Groq is an LPU, that is a language processing unit inference engine that helps this model to run incredibly fast. So for the embedding, we are using Nomic-embed-text, which we are going to run through OLLAMA for efficient embedding. So the Nomic-embed-text is a high-performing open embedding model with a large token context window. So we will use the Chromadb as the vector store to achieve this exceptional level of performance. All right, so as a bonus, we will explore how to replicate this setup locally using the OLLAMA for both Llama 3 and the embeddings. All right, so I've already have made videos on how you can do this using Llama 3 and OLLAMA fully local. But this one is, we are going to implement a high-speed chatbot using that. We're going to run that through Groq. So if you're interested in these videos, do check out the description or check out my videos and get connected to that. All right, so we are using these two documents for the demonstration. These are articles, and this is a model article. Okay, all right, and you can get into my GitHub. So this is the name of the document in my GitHub, so you can just clone it or download it. All right, so let's get into it. So let's look at the demo. So I've already uploaded two documents, which is process, and let's ask a question from this document. So I'm going to say, so let me say the original, I'm going to paste this one. What is the original GPT model? So I'm going to paste it here. Let's see. So this is from one document. I'm going to say, what is the original GPT model? I hit enter. All right, that was really fast. So it's giving us the results. To train this model, the developers collected roughly 1 million prompt response, and it's giving us the sources. So as you can reference from here, right, it's giving us the references and the name. So we collected roughly 1 million. So that is really accurate, right? Looking at the response here, it's really accurate, and it's giving you the resources, the sources of the documents, right? That is awesome. So let me try one more from this document, and I'm going to say, so let me go there and say the document. I'm going to say, who is the CEO of Walmart? I'm going to save the document. Let's hit enter. Awesome. So the CEO of Walmart is, let's see. Oh, perfect. Okay. So so this has a memory capability. So I'm going to say, what did he say? All right. So what did he say? Let's see. It's going to give a follow-up response. Awesome. This is great. All right. I love it. All right. So let's look. So I'm going to build this step by step. Okay. So, all right. So I'm going to walk you through the architecture of how this works. All right. So this is a PDF document. So we are uploading multiple PDF documents, and we are going to split that into chunks. So, all right. So we have chunk 1, chunk 2. All right. So depending on the number of chunks you want to put in, so we are going to convert these chunks to embeddings. All right. So embeddings are nothing but the representation of this text into numbers, so they can be fed into the large language models Right, so we have our embeddings for each of them. So we are storing. So for this, we are using the Nomic-embed-text to store our embeddings, and we are going to pass that to the vector store. So we are using the Chromadb for the vector store. So this is where the knowledge base is going to be stored, so that when the user asks any question, it is going to be converted to a question embedding, just like this one, and it tries to create an understanding, and it gets into the vector store. That is the vector database where there's the knowledge base of your document, and it's trying to find answers. That is called the similarity search. So it's trying to get similarities or get answers, right? So when it gets the answers, it's going to rank the results. So you can have the top three, top four. So you're going to rank those results, and it will be passed to the large language model. So we are using the Llama 3 as the open source model, and it passes the answers, right? So when it passes through the model, it gives the answers. So as you can see here, and the answer is passed to the user back, right? This is pretty simple. All right, so let's get into it. VS Code. So in here, we are going to run our requirements. I'm going to show how you can get the Groq API. All right, so this is the requirement. Pull this down. So we need to install Chainlit, LangChain, community, PyPDF to run the connect to PDF, Chromadb for vector store Groq, LangChain Groq. So we need this to run the Groq, and to run the model through Groq, OLLAMA to run the embeddings, and also run our model. So Python .env to connect to our APIs. All right, so let's get into it. I'm going to open a new terminal. We're going to start from there. So I'm going to say new terminal. I'm going to close this one. And so if you see an environment like this and you wanted to create one, you say Python -m env. So when you hit enter, it should create an environment just like this one. All right, I already have one, so I need to activate the environment. So I'm going to say m/script/activate. I'm going to say enter. So you should see this green environment which shows in here is active. So we need to install this requirement. So if you want to install, you say pip install --our requirement txt. So when you hit enter, it's going to install all these requirements that is needed to run the application. Okay. All right. So the next thing we need to do is we need to get our .env. So I'm going to show you how you can get that. So you go to console.groq.com/keys, API keys, and it's pretty straightforward to create one. So you just go to create API key and you name it, and you just get your API key. So you can copy this and you paste it in here. All right. So let's get into that. All right. So in my VS Code, I have my app. I name it this intentionally, so you can name it in the name you want. Import PyPDF. So you import PyPDF2. So this is going to interact with our PDF, and we import the OLLAMA embedding. So we are going to use the Nomic-embed-text to store our embedding. So we are using that through OLLAMA embeddings. And we import the recursive character text splitter to split our text. And we use the chroma for the vector stores. All right, so we use the conversational retrieval chain to create our chain for the conversation. And we want to keep some memory, so we are importing the chat message history and the conversation buffer memory. So we import Chainlit as CL for the framework. And so we do Chatbot, so we're going to pass our model through Chatbot. and we do .env, so we load the environment variables using the load .env. So we load it. So as soon as we call it, it is going to connect to our .env to load our environment variable that's connect to the API. And we set a function to initialize the conversation chain. So we pass the Groq API key and we store that into Groq API key. All right, so we initialize the Groq chat with the provided API key, the settings and the model name. So we run this model, the temperature, and so we run it to Groq chat Groq, right? So we are using the LLAMA3 70 billion that is within Groq, right? So we want the temperature of 0.2. So this controls the randomness of the output. So if it is closer to 1, it means that it's going to change anytime you run. All right, so this is where it starts. So we on start. So when we want to start conversation, so we start with files equal to none because none files have been uploaded. So initialize the variable to store the uploaded files. So wait for the user to upload files. So we want to see something like content that will be displayed when the user uploads files. So please upload one or more PDF files to begin. So we want it to accept PDFs and we want the max size to be 500. You can optionally change this and the max files to be 10 and timeout is 180. All right, so we process each uploaded file. Right, so we create a list called text and a metadata called text. So we want to iterate through each of the files and we want to print the files that we've uploaded. So we read the PDF files and we store this into PDF. So we use the PyPDF tool and we run that through the file path. Right, so we create the PDF text. So we create a string that is, we are going to read through the file PDF pages and we extract the text and we store it in the string PDF text. So we split the text into chunks and we call it text splitter. So we create chunks of 1200 and we overlap 50. So we create a variable called file text and we pass the PDF text, we pass it here to split that and we extend these texts into we store them here. Okay, so we store all these texts here. All right, so the next thing is we create the metadata for each chunks and we call it file metadata and we want to get the sources. All right, so after getting the sources we pass that into the metadata that we've created here, so we store that into this list, so for each of the files. Okay, so the next thing is to create the Chromadb store. So we use the OLLAMA embeddings and we call the Nomic-embed-text. So we store it here and we create like a vector store and we call it docsearch. And what we do is we use the chroma and we pass the text, and for each of the text we create an embedding and the metadata. Okay, so we initialize the message through the initialize message history for conversation and we want to get some chat message history. So initialize that, we call it message history. And the memory for conversational text, we pass it, call it memory. We want to pass the chat history, the answer, the message history, and we return the messages. So we create a chat that uses the Chroma vector store. So we call it chain. And within that, we pass the conversational retrieval chain and we pass the model, that is the Groq, LLM-Groq. And we call the chain type to be staff and the docsearch as we're going to retrieve documents from the vector store, and the memory is equal to memory and the return source document we say true. So we send an image with the number of files. So we want to get an image. So we pass an image and image is here. It's going to show you when it runs. And we inform the user that the processing file has ended and you can now chat. So we want to see the number of files displayed and you can now chat. So we pass the element here. So anytime you run, we will see the image. So these are the elements, the image being displayed. Okay, so we store the chain in the user section and now we are ready to chat, right? So this is where the message begins. So we retrieve the chain from the user section and now we say callbacks happen. So this interaction between the user and it happens asynchronously. So it happens parallel. Okay, so it's conversation. So we call it CB. All right. And the next thing is we call the chain with user message content. All right. So we call a chain and we call it RES reads. And we invoke the chain. So we say we pass the message content and the callbacks. And we want to get the answer and we want to get the source document. So we call it answer and the source document. So we create a list called the text element and we pass this. We say the list element, we initialize list to store the element. So now we want to get the source document. So we process source document if they're available. We use the if statement to iterate through that. We want to get the source ID and the source document through the source document. All right. So we create the text element to reference the message and we want to extract the page content and the source name and we are adding that to the text elements that we've created. We've already created here, we add it to that and we add the source names as well and we add the source reference to the answers. All right, so for each of the answers, we want to add references to that. So if source's name, we want to add references to the answers, just like this. So it's if else statement and we return the answers. Okay, so now let's save it and run it. Okay, so before we run it, we need to pull. So we say OLLAMA, we want to pull the embedding. OLLAMA pull the Nomic embed text. So let's pull it. See, perfect. So we're done with that. So what we want to do now is let's run the application. So we run it, call it Chainlit, run using this file. So I'm going to say app. Apply. So when I hit run, let's see. All right, so I'm going to upload documents. Let me upload this one. So I uploaded this one. I'm going to upload this one. I'm going to say, let's run it. All right, so let me ask, say, what is model evaluation? I'm going to hit enter. All right, this is perfect. All right, so based on the provided context, model evaluation refers to the process of assessing the performance of it. So I asked the question here and it's giving me a very great answers. All right, so it has the sources. Source one, source two. All right, so let me ask a question from this document. I'm going to say, tell me about tell me about, okay, let me just paste it here. Tell me this is awesome. Well, all right. Okay, it's giving me some context, which is awesome. All right. Okay, based on the provided context, it's a company where Michael formerly has taken on the new role. This is a contest. Wow, this is lovely. So I'm going to show you how you can do this locally. So I'm going to close this one and I'm going to close this one. So for this one, I've stored it here. The only thing you're going to change is we are using the model. So we're going to change this one. It's the same thing. We're going to change this one to Chat-Ollama. And we are using the Ollama embedding. And everything stays the same. So for this, we imported the launching community.chat models. We import the Chat-Ollama to run this. And I'm going to show you how to do this. And I'm going to run it. So this is locally, right? Save this. And we have to pull Ollama. So this one, we want to pull Llama 3. So let me say Llama 3. Hit enter. Awesome. All right. So now let's run it. Okay. I want to run it. So this one, I'm going to say app local.py. All right, awesome. So I'm going to upload the document and let me upload this one. Okay, just upload this one and let me try it and see. All right, so I have my documents uploaded and I'm going to say what is model evaluation. Let's see. All right, this is awesome. So we have our answer. All right, and it says in the context of artificial intelligence and machine learning, all right, model evaluation typically involves comparing the predicted output of the model against using accuracy and all right. Oh, this is awesome and it's giving out the context. All right. All right, guys. I feel this model is performs really well. So I actually use the local through the local model. So I actually run it through Ollama and it's giving us a great result. All right, so this was what I wanted to share with you guys. So I hope you like this video. Do well to subscribe and share. And let me know in the comment section how you feel about this model. And yeah, see you in the next one.